Now on our C8 Corvette, of course we opted for the Z51 Performance package, and that included the Z51 Performance exhaust. And it's supposed to be a little bit louder and higher performance, but frankly, it's not quite loud enough for an enthusiast. So of course we're gonna work with an aftermarket brand to develop an aftermarket exhaust. And one of the best brands in the industry is Magnaflow. So we reached out to Magnaflow and they were excited to work with us. And so we've had the car here for about 7 days, and they've been testing and iterating on the exhaust system for the C8 to get exactly the sound, performance, and thermal profile that they were looking for. And what we want to do is do a deep dive with Rich from engineering to talk about exactly how does the stock exhaust system work on the Z51, and now how does the Magnaflow system work. We're also doing a really detailed recording with a high quality microphone in a controlled environment with a soundproof box to show you exactly what the aftermarket exhaust system sounds like compared to the stock system. That's later on in this video. You're going to want to hang tight and check that out as well. Now make sure you give a thumbs up to the video if you like it, and subscribe to the channel because we've got tons more products. The whole purpose of this build is that we're partnering with brands to develop all the new parts for this incredible new C8 platform. But first, let's dive into the stock exhaust system. All right, so we're here with Rich Waitas from Magnaflow. You probably recognize his face from the Discovery Channel and from other YouTube videos, but Rich has been awesome in partnering with us here. Rich, tell everybody a little bit about yourself. How long have you been with Magnaflow? What do you do here?
Pretty much been my home for about 17 years, and started in the engineering department, everything from testing and validation to working up to the engineering director. And when it got to that point, it was now about kind of explaining the technology that we've incorporated to building it and building a bigger team so we can cover more. Obviously, you've seen the facilities here, quite a few bodies running around. We have a lot of things going on from a technological standpoint. But at the end of the day here, all we're looking at is trying to build the best possible product with the most amount of means we can put in here. And state-of-the-art technology, as you can see in the facilities, is where we're starting.
Awesome, and thanks for partnering with us. We really appreciate it. We're so excited to drive the Vet. And I mean, sitting here talking to you, I'm like, let's go drive it now. But first, let's talk about the stock exhaust system. So this is the stock exhaust system off the C8. It's not the one we just took off of our car, because Magnaflow has already taken this off a car that was in here before us, and they cut it open so we can take a really close look. We're also not seeing the upper pipe that comes off of the cat that has the upper valve. So there's valves all over this thing, and they've run the pipes around through this big chamber. Walk us through, how did the valves work on the system? What did Chevy do when they were sort of designing this for the C8, in your opinion?
So the Z51 is obviously the performance upgrade, and one of the features that Corvette has always had has been this variable exhaust, and that's something that has trickled in from the C6 and up, whether it's a valve for a little bit of noise control down to a kind of the track modes they've put in their NPP exhaust, and this Z51 is no exception to that. The internals here are obviously designed to run a multi-valve system. So the valves that you don't see here are the AFM valves. These are the valves that are designed when it goes into 4-cylinder mode to restrict some of the airflow so that you don't have unwanted vibration, harmonics, noise, and things that cause undesirable sounds with the car. So that valve will open and close as it goes into 4-cylinder mode. The secondary valve is the fun valve. This is the NPP valve. This is the one where you want to pop it onto the track mode or the sport mode to get a little bit more feedback and a little bit more sound. Now, to understand how all that works, you kind of have to see some of the internals, and we've kind of windowed this so you can see exactly where the parts are and how they function. So first and foremost, let's talk about the air path flow, and you'll see that here's the engine inlet on either side, comes in, and you'll see both of those pipes enter either side of the X pipe. And if you've seen our system before, which we have released a few models, you'll see that they both enter on opposite sides, crossing the X pipe and then traversing into these other pipes that you'll see that pretty much dead end here when this valve is closed. You'll see that there's 4 holes, or approximately 3/4 of an inch, and that's where all the flow is going to go when the valve is closed. That means it's got to go through those holes, expand in this entire chamber, and you'll find this 2-inch outlet that's got to work its way through before it comes out here. All of that is basically going to create some restriction, some baffling, slowing down the gases, creating a basically lower frequency, but also a more mellow tone. As that valve opens, it's going to go through the path of least resistance. It's going to completely skip all of this chamber. It's only got those 4 holes to pass through. We'll get some expansion in there, but for the most part, high gas velocity, high RPM, it's going to go right through the valve and come straight out. So that's what gives you the both modes that you have, and why there's such a discrepancy between what would be the touring mode and the sport and track modes.
And that valve's fully open at wide open throttle, but right around where in the different modes and in the different throttle positions is that valve opening up? Like if I'm driving along in sport mode and I want to pass a car and I go into 50% throttle, what's your guess on roughly how open the system is at 50% throttle?
So there's a lot more to it than just the actual throttle position, and that's something that we've been here obviously using the cars to determine what's going on. So we've got all the electronics, and obviously you see we've pulled the valves off here to kind of study how the airflow works. And what we're doing is mapping out when that happens. So there's a couple of criteria. The valves open and close at different mile per hour. So there's a minimum threshold where the valve opens, it's based on mile per hour. So when you're at low speed and low throttle position, you're gonna find that the valve remains closed and you have a very quiet cruising tone when you're in touring. When you're in sport, you'll find that there's a more aggressive open, and a lower throttle position will begin to open quicker. When you're in track mode, it simply opens the valve from the beginning. So the secondary valve will be open regardless of mile per hour and regardless of throttle input. So in the Z51, the 3 different modes, there's slightly more progressive intervention of sound that they've allowed in its design. And we're gonna map out more of those features as we get more of the cars in here, but right now that's what we're literally doing is we're pitting out all the electronics to determine what exactly it's doing at the exact given point, and that's all that dyno work we're working on.
Nice. And you mentioned that some people on the internet were buzzing about why did Magnaflow use an X pipe, which we haven't even talked about your system yet. But people were saying, why did Magnaflow use an X pipe in the system when in actuality, Chevy did exactly the same thing, and the system that Magnaflow is designed much the same.
Yeah, the basic characteristics and the sound that you're looking for, one of the most unique things about this muffler is its orientation. It actually hides a lot of the architecture, and really when you start to see the similarities of our design that we've derived from this, you're going to see a similar X pipe, you're going to see similar pipe lengths, you're going to see larger diameters for enhanced airflow, but for the most part, we've taken what GM has spent millions of dollars in developing and creating a system that functions, and we've enhanced it to create a sound that we like that also performs in a way that we want it to as well. So you say, well, this thing looks like a big chambered exhaust, it's probably packed, but actually if you've actually knocked on these exhaust systems, you'll see this is a completely chambered exhaust. There's no packing in here whatsoever. A lot of that contributes to why there's a heat shield. And that's another big part of the study that we've done, is to actually look at how changing the body shape and the heat and the density of the materials is affecting the heat transfer, and that's a big part of the program. But when it comes down to airflow, that X pipe that we have is basically a derivative of this with a larger diameter tube feeding, but for the most part uses that same thing. And why? Go back to the C6 and even the C5. The C5 had an H pipe. It had a small crossover tube with a port in it that was in the early models, and as it got bigger, the port got bigger because they realized that balancing had an effect on the sound as well as performance. Got into C6, this X pipe starts to rear its head. This is very similar to the same X we've been using for well over 25 years in our True X exhaust systems. And now if you peek inside, you'll find almost a very similar design that you saw in the C6 with a 2 3/4 inch diameter, and now we've incorporated our X pipe with 3-inch inlets and outlets as well. So the design is very derivative, and that's because it provides some of that character. X pipes and H pipes, they have different sounds. And that's one of the things that we want to preserve, is this is still a Corvette, and we still want it to sound like a Corvette. That LT2 is a sister engine to the LT1, and we still want it to have that same grunt that the LT1 had.
Nice. And the sound level, right? So you guys have actually tested the stock exhaust system with the dB meter to understand, like at full clip. What was the output, roughly, the dB level of the stock exhaust?
So depending upon the testing, we were doing more relative testing to find out what the approximate sound levels would be to interior and exterior. There's a bunch of different design standards you can use. There's SAE, and they have the 1169 and the 1649, and those are more standards that are out there for evaluating total sound for compliance levels. We were more interested in what exhaust does for the driver. This is a car that was designed for a driving experience. The rear engine, mid-engine setup and rear exhaust really puts all of the noise making behind the driver, which means you lose a lot of that natural feedback. As a C7 owner, one of the things I know, that tunnel gives you a ton of that exhaust note as all the exhaust is passing through, and gives you a feedback so you're not necessarily staring at your tachometer to find out where your engine is. You've got that auditory feedback. Yet, we don't want the undesirable drone or noise when we're cruising, and those are all the elements that we're looking at with final design. And what you were looking at for DB, we have a couple different variations, and we're targeting something that's going to be in that 95 to 98 dB in the cruising mode, and then in the more aggressive track mode, something that's going to be a little bit more than that. We've got a couple models that are up into the 100 plus zone for those guys that really like that racy street pipe sound of a racetrack type car. But we're not sure exactly where we're going to go with that, and hence we're going to give you both options to kind of play with and see what you guys give us as feedback.
Yeah, and I think that makes a lot of sense too. I know in your production product, when it comes in the box, you're going to give people the options. There's going to be multiple configurations,
right.
And we'll go talk about that system in a minute. But that was my biggest complaint, I think, with the stock exhaust system was I felt like inside the car I wasn't getting the sound that I wanted to know whether or not the car, where I was in the rev range. And I think it was louder outside. I think if we did the test in our studio with the audio, and we'll compare it to this and actually show those dB differences. And of course, the Magnaflow system is going to be louder, but I'm really excited for that in the cabin experience, which I know is something that Magnaflow focuses on a lot and a big part of the reason that we're here. But let's go talk about. How much does this system weigh? I think we determined that the pipe and the valve before this system was going to be roughly the same weight. How much does just the sort of second valve system back weigh when you put it on the scale?
So everything from the valve back that we've done, we've reduced the mass without the outer casing. Obviously, with some of the different tubing profiles and the material that we're using, we're looking at a weight savings of anywhere between 20 to 25 pounds at a minimum.
Wow, okay. Compared to what does the system weigh now?
So we're looking, this rearmost section here is close to about 57 pounds.
57 pounds.
And we're going to cut off about, anywhere between 20 to 25 pounds from that.
Geez, on the low end, 20 pounds against 57, that's more than 30% weight saving. That's big. That's awesome. Nice. Well, let's go take a look at the Magnaflow system. Now, obviously, before Magnaflow's even building anything, they're working in computer-aided design, CAD software, and modeling everything out before they're building this stuff. So, Rich, walk us through the system you guys are using and what you did on the C8 here.
With everything we do, we want to document where we start, and this is kind of an idea of what happens when we take your exhaust and we scan it. This is one of the preliminary scans. As you can see, we've got a little bit of a 3D profile here, and it gives us some orientation on what is where. So we know our most important inlet points. We know where the outlet points have to be, and we can start doing some design work off of the vehicle. And this is where we come up with our preliminary design. And as you can see here, that's our profile. We have that similar X that we saw in the factory system also incorporated into ours. We've just enlarged some of the tubing diameter, and of course, we're trying to enhance the sound, change the sound. Our mufflers are much smaller to give you more feedback. Now, we want to say, hey, how does this relate to factory, and how do we show we have good compliance? Well, if you overlay the two, you're going to see where our design is derivative of. The X is in a very similar position. It has a very similar function, and we know its functionality is going to work because of all the time GM's put into creating their design that we're mimicking some of the aspects of and then changing to make them work in the context that we want them to. But here it gives you a good idea. So this gives us a very easy point to start an exhaust because we know where all the hot points are and we know the boundaries created by factory. So our system definitely overlays the factory system well. All we're doing is pulling out some of the very radical bends, as you can see here, the very sharp bends that they had with the tips to a more broad bend for better airflow. And we reduce that muffler size and the complexity of the internals to give us a little bit more airflow.
And you can definitely see how much less material there is, and that's also why you're able to have such incredible weight savings in the system. Awesome. So now with any exhaust system, there's obviously several different objectives any owner might be looking to get. Weight savings is a big one, power gains, but frankly, for me and most people, it's sound, right? You're looking to get this thing opened up and hear that engine and open up those throaty tones, maybe even a little bit of raspy, racy sound. And that is the reason why we brought our C8 here with Magnaflow, is to partner with you so you can finish the development of the sound profile of this system. Now, for me, not being an engineer and not being sort of really familiar with how that works, I didn't even know what was necessarily entailed in that process. You told me you've got a ton of different iterations that you've tested here, and this is not the full exhaust system, obviously, for the C8, but these are the different components that lead into the sound. So walk us through each of these different components and how you go about establishing the sound profile for the car.
So in every vehicle, there's a character to it. We kind of talked a little bit about the stock exhaust, the LT1, LT2. They have that inherent, Corvette sound, and we want something to bleed through about that. There's a lot that's about this car that will always remain traditionally Corvette, and the engine really is, for the most part, a derivative of the LT1, and we want that similar sound. Now, the exhaust being in the rear of the car, the length of the tube is going to change some of that character, especially with the very large chambered muffler. And one of the things we've had in our first iteration was a more traditional Magnaflow component, and that is a fully packed muffler, very dense. Basically packing material, perf core, straight through design, gives you all the airflow, but it gives you a very deep baritone note. Now, one of the things we found in a lot of the feedback we've got from yourself and a lot of the consumers out there was that this car has a different attitude. Physically, it has a different character, and it should have a voice that matches. And that's when we went to a deeper dive and we said, hey, we need to borrow a car, bring it in here, and explore some of the other options to bring back some of those racy elements. And what you see here, this is just 4 of, I think, the 5 iterations we've created of different designs with different internals. And we went everywhere from, this is a perf version of this that's a chambered empty no packing material, to one that's a hybrid of a chambered and a straight through, and the hybrid to an all-out straight pipe. And we got a little bit of everything here for everybody. Straight pipe isn't for everyone, but we had to put it out there to check and see what that car sounded like.
Yeah, I'd like to know what the straight pipe sounds like, because it always sounds awesome. And what did we end up with on the car here? It's the full perf version?
So what you have is what we're gonna probably come to market with, and that's the thing that we haven't really finalized yet is, as you can see, the system is fully V-banded. We may include multiple options for that end user, because maybe the straight pipe is what you want for the race day, but we want to be able to change it out readily. And we've come up with a system that allows you to basically remove one under panel, not remove the whole body panel to replace the parts. So having interchangeable parts is a viable option, but where do we want to go? We have a deeper, more baritone note, a little more conservative, a little less race and pop. We have the full perf chambered muffler, which basically gives us mid-range, a little bit more throatiness, but not a lot of differentiation on the sport versus the touring modes. Yours has the one with half perf, and it's sort of like the hybrid, where it gives you a little bit more character when the depth comes out in the touring modes when you're cruising. But when you switch it over to the bypass mode, it's like a straight pipe internally, has a little bit more control than the true straight pipe with about the same amount of airflow. So we've kind of investigated how all of this works on the dyno as far as power detriment and power support. And really all of these iterations are about what creates that right character. Do we want that pop and decel cackle of a race car all the time, some of the time? And these are all the different internals. And obviously when we build them, they all start as basically a coil. And we can pick out not only the perforation pattern and the density, but where we punch the holes, since we actually make our own perf in-house, how much of there, and that's what we're talking about. We had that 50% perf inside of yours, which will be, I think the profile will come to market with. It's got a little bit of that character, not too much, but it also is completely drivable without the drone. A little louder than the pack muffler, a little less deep. That's our conundrum that we have to figure out where exactly we want the balance. But we're very happy with the version that we've created here.
Excellent. When we were setting these up on the table, I couldn't help but notice that this feels like it's probably close to 20 pounds, maybe 16 to 20 pounds on that packed version, compared to the straight pipe, which obviously feels like maybe only about sort of 5 or 6 pounds. So this, as we were talking about with the different configurations that people choose, is going to be the difference between a system that's 15 pounds lighter than stock to 25 pounds lighter than stock, like getting close to almost half the weight of your OEM system. The valves are something that, obviously you're using Magnaflow valves. What's the difference between the Magnaflow valves and the stock valves from Chevy? Why not just reuse their valves and swap them out in the system?
One of the big things that we were looking at in designing our own valves, they come at a pretty high cost because these are obviously cast 304 stainless steel, so they're weldable, as well as things that we've created that have a somewhat universal design. More and more vehicles come with either a modular bimodal or a active exhaust system. So we've come up with a design that we can enhance airflow. So one of the things, the factory tube diameter on the outlet is 2 1/4. We wanted 2 1/2. The AFM valves are 2 3/4. We wanted to go to 3 to provide extra support. Supercharging is going to probably be one of the more common things since the LT1 platform has that ability. Watching that probably migrate to this is something that's going to happen. So we would anticipate giving somebody some more airflow, as well as still making sure it makes power in the stock setup. So we had valves created at these more standard diameters within large capacity, and then we simply adapt them to the different functions. If you're a big fan of the Corvette line, you'll see that this is the bolt pattern for the actuator for the C7. And this is the new one. These are 2 of our actual test pieces that came off of the prototype vehicles. And this is the new valve, and the difference between the new valve is it has an actuator arm. So it changes the ratio that the valve opens relative to the turning of the motor by the actuator. And they do both use the same actuator. So by putting the arm on there, GM can create a different functionality for the AFM valve in a ratio that works differently than it does for the MPP for sound. What that also means on our side is we've got to develop a mounting system that works with the actuator arm. So we build these in-house. We can laser cut whatever we need to fit. But there's also a big consideration. If you notice the coloration on this, it's got a lot of heat. You can see some purple and bluing in here. You got to remember that these valves are also in a position now where they're the closest to catalytic converters that most of these valves have ever been. In the Corvette previously, there's a 4-valve system, but all 4 valves are 8 feet away from where the engine source is, and from the last cat at least 6 feet away. So they're not storing that energy. So durability and the ability for them to last through all that heat cycling, the bushings and the materials inside all have to be correctly identified. So as in your case, we are putting in the stock valves while we are still testing out additional variations of this to make sure the product's going to function, whether racetrack or on the street.
And you're reusing the motors to turn the valves. It's not a new motor that's replacing. Obviously helps keep the cost down and no reason to replace.
The biggest concern is really understanding how the computer communicates with them. So to re-engineer a complete electronic system, I'll tell you, we're an exhaust company. That's not our forte. And for us to farm out that work and try to assume that we can build a better valve than GM has spent all that time building, that's heat insulated and can communicate properly with the computer, we'd be in development even longer than we already are with this vehicle. So we're relying upon the factory electronics and mimicking the pathways and opening and closing so that the computer's happy with the functionality of the part we've created.
Sense to me. So when we've spent all this money on an exhaust system for the performance and the sound characteristics, the only part of it that's actually visible is the exhaust tips, right? This is the beautiful part of the system that sticks out from the back of the car. Tell us a little bit, what are the tip options that you're going for on this system?
So we have, what's on the car now is this kind of heavy stagger and a stainless. And as you kind of saw, we've had some carbon stuff out there. We have played with some of the material, and in that very aggressive stagger going to the track, we've seen some degradation because the tips, if you can see on a heavy stagger, if they were right next to each other, they're going to burn the edges. So we're looking for a material that can hold that, or changing the orientation and design. And as you can see with the second set, we've got one that's more flush. And this, if the exhaust gases are coming out, you're going to find that the exhaust is not going to burn the tip, so you're not going to have that same problem of damaging the carbon fiber. The tips are important, like you said.
Yeah, I like the carbon fiber a lot. When are you anticipating these to be ready?
Obviously, I can see that, and we've got that same message from some of our consumers, and sometimes that's the carbon. They want a premium kind of feel and a premium look, but we're also looking at an option to go back to a stainless option that might be a ceramic-coated black, so we can still have the black and investigate some of the durability of a high-temperature ceramic. But obviously, carbon's carbon.
All right, well, we can't wait to see what the end kit actually looks like. We get to experience it and drive it home. We have the first production kit of the Magnaflow exhaust system for the C8. This kit's going to be available for pre-order on Motoroso.com. Reach out to us, put your name down on the list, and of course, if you're watching this a couple months after this has come out, that system's ready to go. Rich, thank you so much for taking the time to hang out with us and do this project with us. We really appreciate it.
Happy to help.
So we can't go into all that deep technical information with Rich about how the sound profiling is done and not give you a little snippet and a taste of what this thing actually sounds like. And we're in our studio here back in San Luis Obispo, and we've been recording our full sound video, which is gonna be over 10 minutes. We'll put a link to that in the description, and here you're gonna wanna check that video out if you really wanna hear how it sounds, but we're gonna give you just a little bit of a sneak peek of what this thing actually sounds like.